Hello and welcome to the JENEsys Edge VAV Configuration Tool Deep Dive. My name is Charles Johnson, lead trainer and technical engineer at Lynxspring. Today, we're going to be going over in depth the JENEsys Edge VAV Configuration Tool. We're going to be creating the spreadsheet that will be used later on with the Onyx Rapid Network Integration Tool. Which is actually in Workbench itself with the Edge Supervisor. So this tool actually creates the spreadsheet that we're going to be using later on. Prior to this configuration tool, we just gave you a spreadsheet itself with a bunch of different drop-down menus, and you manually had to add things in order to set up a VAV configuration as well as the network integration. But now, with this tool, we pretty much, this will generate the spreadsheet that's needed. So let's go ahead and start with the start screen here. So I've got the new menu, or I'm sorry, not the new button. This actually opens up or creates a new project. Open will open any existing project that we have. Obviously, the exit button closes out the program. And the template editor is where we will create, let me go ahead and bring this over here, is where we create templates that we can use later on when we configure the VAVs. And we can, it mimics the control configuration, flow configuration, and the input outputs tab that we have here. And I'm not going to go into creating a whole one here in the template editor video I did earlier in the series. We already created one. It's actually very easy to do. Okay, so this Onyx ASC compatibility here, this is actually going to be going away in a later release. We were going to go with a way to keep track of modules, but we decided that that was not very it wasn't going to be very useful in the long run. So this will actually go away, but currently this actually does nothing. It's effectively a placeholder. Okay, so we're going to start with creating a project right now, and I'm going to go ahead and select new. And I'm going to name this classroom. So we have the base configuration tab, and then we have the assignments tab. The base configuration tab is going to help us create the structure for the air handler zones and the VAVs. And then the assignments tab is what we're going to use to assign the air handlers to the zones and which VAVs belong to all of this. So you're going to see the air handler as the main thing, then the zone underneath that, and then the VAVs associated with that zone, which is associated with the air handler. Okay, so let's start with the number of air handlers and number of VAVs. If this per zone is selected or checked, once we add a number, let's say 5 here, and we do per zone, it'll, however many zones that we have here, it'll put that many per zone. So if you have an even number across all the zones, feel free to go ahead and check this box. Otherwise, just keep it unchecked. So today, we're going to have 2 air handlers and a whopping 5 VAVs. Actually, as a matter of fact, no, we're just going to do, no, we'll do 2. Which is fine. So I'm going to do 3 in one and 2 in the other. Okay, now for zones, it is best practice to use camel case, no special characters or no spaces really. Floor 1 works, like floor 2 works, floor _1 works as well. You know, those kinds of things. And in order to make sure you get the next one, you just go ahead and hit enter, floor _2. If you try to connect here or click here anywhere else, it's not really going to do anything. So putting in floor 1 and floor 2 here are fine. Now, if you had multiple, if you had more zones or whatever they needed to be do, you just add them here. Now, with the naming structure, we have the prefix, the body, and the suffix for our air handler and VAV naming structure. And so currently the body is just checked. But if we were to have something for the prefix and the suffix, we would go ahead and check these boxes here. This increment box is automatically checked, which means it'll increment the number of air handlers and VAVs that we have based upon the number that we have in the that we filled out here in this field. Then we have the zeros column, which will place leading zeros in front of the number up until we have 10. So if you had 100 VAVs, it'd be VAV 01, 02, or 001, 002, 003, etc. And then it would be 010. Then once you get to 100, it's fine. Or let's just say 1 through 10, 01, 02, and then 10. Then we have the default network settings. We have to put this in here, and we do want to keep this checked as an increment. So what will happen is for every VAV that's created, it's just going to take the starting IP address and add 1 to it. Now we have the IP address, subnet mask, gateway. The MAC address and the host ID we don't necessarily care about unless you had them all, but we typically don't. The IP address is going to be the starting one that we have. However, the gateway is equally as important. Even if you do not use the gateway address anywhere else, it needs to be present in the system. So I'm going to start with mine, and this is my local demo board here, 192.168.1.182 is going to start my VAVs with a gateway address of 192.168.1.254. And now that I've added my IP settings here, and I've got everything the way that I would like, I'm going to select Build Table. And now it builds a table of the air handlers, floors, and VAVs. And now I can go to the Assignments tab, and I see them populated in each of the data fields here. So I'm going to go ahead and select Air Handler 1, Floor 1, and then double-click VAV 1. Now you can actually select multiple zones, or let me rephrase. You can have multiple zones per air handler if needed. Right now, for simplicity purposes, floor 1 is going to be air handler 1, and floor 2 is going to be air handler 2. But like I said, I actually could, in theory, do all this. If I had selected per zone, then this auto build tree will automatically be selected because it'll put all the VAVs in the correct zone that I need to do. If you make a mistake, you can go ahead and reset the tree and be done there. The buttons that you see here at the bottom of the base configuration and assignments, the close button goes ahead and just closes the project. Reset all, it wipes out everything that you've done so far. Save project, it would save the current project. If you need to reload the project, it'll reload the current project. And then obviously begin VAV configuration. Once we have everything that we need here in our base configuration and in our assignments, we are going to select begin VAV configuration. This brings up the same 4 tabs that I talked about in my other videos, the basic configuration. This will go ahead and allow us to assign templates to the VAVs. We get to name our station of the VAV if we want. That can be important for later on. We can also name the VAV and give it a room name. Now, the importance multiplier has to deal with weighted outputs. And pretty much what will happen is we have a lot of trim and respond programs. So like a static pressure reset, supplier reset, those kinds of things, we are using with the trim and respond program. And so with the importance multiplier, we can actually weight we can weight controllers more importantly than the other. What I mean is, like, let's say I have a hospital, and let's say I have an air handler that serves 2 OR rooms, 2 VAVs in a hallway, and a waiting area. Well, the waiting area in the hallway, they may not be that important to have heating or cooling or any kind of what we call requests for heating or cooling or pressure requests. However, we absolutely need to make sure that when the ORs are in use, that they take over for priority of cooling. So we can actually weight them higher. The larger the number, the more of a weighted output. So I like to do 1 to 3, but of course, based upon your specifications and your based upon the specifications of your job, that may be something you have to do and determine what importance multiplier. Then it'll fill out each device here. So if I go ahead and start to expand these, and I click on this, you can see the station name has already been filled out. The VAV name is filled out. The importance multiplier, as well as my IP address, my subnet mask, and my gateway, as well as the zone. Now, a couple things here that we have a AHU rooftop name and RTU IP address. So the RTU, AHU RTU IP address, this doesn't need to be added. If you had, a device that was an IP device, whether it's backed over IP or like an Edge 534, you would put that in here. But it's not really needed. However, what is needed, and it has to match exactly the supervisor name and the supervisor IP address. If they do not match, when you attempt to import with your Onyx Rapid Integration tool in Workbench, you may get an add failed, and you'll have to go and look in the application director for the specific error. So one thing that you may notice is that when I multi-select VAVs, certain things get disabled. For example, no VAV can have the same station name. No VAV can have the same IP address. So those things are disabled to make sure that we don't do anything. They can have the same kind of template if I wanted to apply a template there. But more importantly, I like to select all my VAVs and put in the supervisor name, and it has to match. So mine is called Edge Supervisor. And the IP address of said Edge Supervisor, 192.168.1.21. I'm not going to put in the RTU name and the IP address. I may do that later. I may rename my air handlers, so I'm not really worried about that just yet. However, I want to make sure that the Edge Supervisor and the IP address of that supervisor is saved to each of these VAVs. So anytime you make a change, I would absolutely hit save to tree. It's really important. Save early, save often. That's kind of my motto. And I take that among anything, regardless of whether it's doing something like this, or if I'm in an Edge controller or a Jace, I like to have multiple saves for my station to make sure that in case of a power reboot or whatever, or a power loss, I don't lose as much information as I need. So we can see that with every VAV, not only now does the Edge Supervisor and the IP address match, but every IP address changes. And this was all done in the base configuration in the assignments tab, or really the base configuration tab is where this came from. It populated from there. Okay. And now I'm going to make sure that I just have VAV1. Okay, so that's what the base configuration does. The control configuration will allow me to change what kind of control I want for my air handler. So we have 27 different types of applications, from cooling only to up to a no fan 4-stage of heat, a hot water valve that's either modulating or floating, SCR control. We have those flavors in parallel fan and series fan, but only up to 3 stages. And that's because we only have 4 DOs. Then we have dual duct applications, and we have a ventilation application. Then we choose whether or not we have an ECM, which is going to be a variable speed for your fan. Then we determine whether or not we have CO2 from a digital thermostat, or if it's a universal input, or from the Niagara network itself. If we have to get the value from there, we would choose where we're going to choose that value from. Then, if the box had any kind of auxiliary heat, and we have analog, digital, and floating for fin tube radiant, unit heater, and duct boosters. Then for the space sensor, we have the 10K thermistor. We have a digital temp RH, an RH with CO2, or an RH with CO2 and VOC. This digital temp here comes from a variety of backnet sensors that we may have. One can be from either the Viconics 8350 or the BW437 that we have a template for, a cubic sensor, and one other sensor I can't think of the name of off the top of my head, but it's pretty sweet looking. As a matter of fact, I can actually look at that real quick and find that out for you, or really for me as well. So the VAV, I'm going to go ahead and look at the station offline here real quick. And we can share the following devices. So it's either the BW437 or the AM6108 is what it's called. That's actually the cubic. That's actually the cubic sensor. It's a small one. Looks very sleek, very nice. You can actually search it up again. AM6108. You can actually look it up in Google, and it's a pretty nice looking wall sensor. But anyway, so that's with the control configuration. We choose what we want. So VAV1, I am going to make it a cooling only box. But it doesn't make sense to have a discharge air sensor on there, so I'm going to select no discharge air sensor. Now, with the exhaust fan, we can either go off of the occupancy of the VAV. We can go from a command of the Fox network. We can go off of the cooling set point plus a differential, or we can go with the with a higher heating temperature, with a higher higher cooling set point. Like, it doesn't come on until it's like, until it gets like 90 degrees. So this would be like more like your exhaust fan to try to just flush out any warm air possible. But we'll go ahead and add an exhaust fan based upon occupancy here. After we've done anything with our control configuration, we're going to go with the flow configuration. And here, with the VAV manufacturer and box size, we have 83 different boxes off the top of our 83 different selections that we have with manufacturer and box size. And if you look in the JENEsys Edge VAV user guide, I believe it's Appendix E, that will actually have all of the settings with the CFM at 1 inch. Plus, we actually have 10 different custom boxes that we can create for this specific project. And what I mean by CFM at 1 inch, if I go ahead and select this Cairn standard 8-inch box, so the CFM at 1 inch shows up. This is actually, if you are at a VAV, this is actually the, when you're looking at the chart, this will be in the control cabinet of the VAV. Says, hey, based upon the CFM at 1 inch, we're going to be reading 904 CFM. So this actually starts starts reading airflow based upon this number. And then the K factor here, so you may see this as K factor. We call it CFM at 1 inch, which by definition is really K factor. But then we actually have this K factor, which is more of an offset. So by 1, if it's 1 currently, it means it's going to read, let's say 904 at 1 inch. And then go up and down based upon that. But this is where we're going to take the calculated flow and take the difference between that and the measure airflow, divide that number, and that will be this K factor number that we get. And that's what we'll put here. Then we can determine whether or not we have a pressure dependent or pressure independent box. Remember, a pressure independent box reads airflow, a pressure dependent box does not. Now, as far as occupied flow, reheat flow, etc., we're going to go ahead and just put in some numbers here. So I'm going to say the occupied flow for this 8-inch box is 120, and we're going to make the maximum flow 760. And let's say for the reheat, we're going to say it's 120 as well. And we're going to go 120 for the max. Then the standby flow and unoccupied flow, we're going to keep at 0. If we had selected our box for a dual duct application, then this would actually become enabled and we could change this as well. But because I have not, this is a cooling only box. Currently, the cooling or cold deck side is available. Now, you can also see that this save box here is not lit up. That's because I've not chosen a custom variable. If I do a custom here, now we can see that this CFM 1-inch box, this goes blue, and the save box now becomes enabled. So if I said, 456 here and then select save, now for under custom A, I can give myself a custom VAV for this specific project, and it'll be unique to each project. So technically you have like 93 different options per project that you have, which I think is a massive amount, of selections already out of the box. But I'm going to go ahead and not save that there. I'm going to go ahead and go back to my current standard 8-inch box. Now that I've set up this particular stuff here in the flow configuration, and I'm satisfied with this overall, I'm going to go to my inputs and outputs tab. And now we have here our analog output configuration, we have our digital output configuration, and we have our universal input configuration. So we have 4 AOs, 4 DOs, and 6 UIs. So this comes up with a total of 14 points, or 14 inputs and outputs total. Now there is a 15th input. However, that is actually the pressure sensor that we have that's built on board that doesn't require any configuration whatsoever. But let's go ahead and start with the AOs. If I keep everything default, AO1 will actually be the damper actuator. AO2 will be the auxiliary heat. AO3 is the reheat. And AO4, I believe is either the ECM or the hot deck. It's one of those two. It is one of those out of the box by default. However, we can change these to whatever we would like just simply from the drop down menu. And of course, we have actuator. This is the damper actuator that you will be purchasing for the Edge VAV because there's no integral actuator available. Auxiliary reheat if necessary. That's an analog. Heating valve, SCR reheat, so the electronic reheat coil. And then the hot dog actuator, and then the ECM. So ECM, for those of you who aren't familiar, fans can actually be a variable speed on VAVs. This either can be a fixed speed from the balancer setting, or it can be variable based upon something called like primary air tracking. So pretty much the ECM will ramp to a speed when you are in heating to make sure that we match the flow that's coming into the box. And then as we go from minimum to maximum flow, the fan will actually ramp up to maintain minimum to maximum airflow on the cooling side. Then we can determine what kind of voltage we want, whether it's 2 to 10, 0 to 10, 10 to 2, and 10 to 0. So obviously 10 to 2 and 10 to 0, this represents a reverse operation. So therefore, if we select that, we know that the damper is backwards. Then for the digital outputs, we have options of doing the fan relay, heating stage 1, 2, and 3, floating, drive open, and drive close, the auxiliary heat, and if it's floating, we can do that here, and then an exhaust fan relay. And as right now, I'm going to keep everything here by default. By default, I believe the fan is stage 1, and then I think it's I think 2 and 3 are the heat, and then the 4 for the exhaust fan. Then for the universal inputs, we have six. Now, UI3 is the actuator feedback. The actuator feedback is required if you are going to be doing continuous commissioning on these VAVs. And I'm going to be discussing continuous commissioning in another video, but that will be set up for UI3. Now, UIs 1, 2, and 5 are all resistive type inputs here. So space temp, set point, and discharge air sensor, that is across them all. UI4 is our binary input, so our Boolean input here. So VAV fan status, occupancy switch, a window switch, or an exhaust fan. And then UI6 is actually a digit, or is actually a voltage input, much like UI3, which can be set up for CO2, hot deck, or the actuator if you wanted to. Most time I see it as UI6. However, one thing that it is to note here, that even with the universal inputs, currently in our the current revision of VAVs, we actually have to go to each of the boxes itself and change our universal inputs. It does not actually push the configuration down as of yet. It will push down the configuration for the analog output and the digital output, but it does not put, it doesn't actually push it down for the universal inputs yet. So in the video for the Onyx Rapid Integration tool, I have a section called Configuring UIs, and we will be doing that there. However, currently I am very satisfied with VAV1, and I'm going to go ahead and hit Save to Tree. And to kind of speed up the process here, I'm going to go ahead and go through VAV2, and I'm going to select a template here. And it's going to ask, it's going to overwrite values, and do I wish to continue? Now, it doesn't overwrite any of the values here. What it does overwrite is the control configuration, the flow configuration, and the inputs and outputs. So when I do that, I'll go ahead and hit save. And as a matter of fact, I'm going to change my flow configuration here. I'm going to change this to 760 as well instead of just straight 120, and save to tree. So for VAV3, I'll go ahead and save that. And again, the control, you can see changes. We'll save to tree. VAV4. Going to go ahead and select the VAV4 template that I have and save to tree. And then VAV5. Do my template there and save to tree. Now that I have the box, or all my boxes the way that I would like, I'm now going to select Build XLS. And this actually builds the spreadsheet for me. Now, if there are any errors or warnings, it will go ahead and log them here for us and actually create a log file for me to review. However, I have created this successfully without any issues. So let's go ahead and find out where this spreadsheet is. And this spreadsheet is located under my C drive, my JENEsys directory, my Edge VAV configuration tool directory. Then I have projects, a classroom project, and then that's where the spreadsheet is located. So I'm going to go ahead and bring up File Explorer. And I'm going to go to my C drive, my JENEsys directory, my Edge VAV configuration tool, my projects folder, the classroom, and now the classroom spreadsheet. So I'll go ahead and double click this and bring it up so you can see everything that we have. So all my station names are here, my VAV names, the IP addresses, the importance multiplier. I have different types of boxes that I wanted. Here are the CFM at 1 inch, the CFMs at 1 inch. Here are all my flow settings that I have, stuff that I want to read from CO2. You know, I've got some fin tube radiator stuff here too, discharge air sensors, an ACI space sensor here as well. I've put the Edge supervisor. I've not put the room name here. I could put the room name if I wanted, but I'm not going to. But again, the edge supervisor name and the IP address, they are important to have here and they must match. Then I have my floor and zone schedules here, as well as the rooftop units that I'm connected to. Um, any additional other settings that I have here. We can see that all the UIs that we have, DOs as well as the AOs. And again, remember, you have to configure the universal inputs at each VAV, and we'll be going through that in another video. So now that I have, I feel very confident about my spreadsheet, I'm going to go ahead and close this out. I'm going to close this. I'm now going to go ahead and save this project and then select return. So now I'll go ahead and click Save Project again and go ahead and close out of it. And I'm going to go ahead and close out my Edge VAV configuration tool. And the next video that you're going to see will be dealing with the Onyx Rapid Integration. So thank you very much and have a good one.